In this screencast, we're going to look at the answers to the Chapters 7 and 8 test review worksheet. And our test tomorrow will cover quantum numbers, electron configurations, and the bonding unit. So we're going to first go over the answers to the Chapter 7-8 test review, and then I will remind you of some of the worksheets that we did on quantum numbers and electron configurations that we've already gone over the answers to that you would need to look over as you prepare for the test. So please edit your papers, and then if there's any of these that you need for me to explain tomorrow at the beginning of the class, I will give you an opportunity to do so. Number 1 is the type of bond consisting of a shared pair of electrons is a covalent bond. A shared pair of electrons is a covalent bond. Number 2, the type of electronegativity that an atom would have if it has a strong attraction for the electrons they share with other atoms, that is a high electronegativity. A high electronegativity. Remember, electronegativity is the ability of the atom to pull the electrons towards itself when it's in a compound. Number 3, what type of covalent bond occurs when electrons are shared unevenly or unequally? That's a polar covalent bond. So one atom is substantially stronger than the other in terms of their electronegativity, so it has more ownership or dominance of the electrons. They're pulling harder in that tug of war. Number 4, what type of covalent bond occurs with two identical atoms share a pair of electrons? That's a nonpolar covalent bond. So if your atoms have the same or very similar electronegativities, they're going to share equally. That's a nonpolar covalent bond. Number 5, what type of bond occurs due to the electrostatic attraction between positive and negative ions? That's called an ionic bond. Number 6, Vesper theory is based on the assumption that the valence electrons repel each other, thus the acronym Vesper, valence, shell, electron, pair, repulsion theory. Number 7, bond length is equal to the distance between two nuclei of an atom at minimum potential energy. Remember, we said that atoms want to have a low potential energy. They want have a low potential energy, which means they're at their ground state. That means they're at the minimum potential energy. Low potential energy is minimum potential energy. Number 8, in which of the following are electrons shared unequally? So you're looking for the molecule that would have atoms bonded that have different electronegativities. So it has to be HCl because hydrogen and chlorine have substantially different electronegativities. Hydrogen is a 2.1 and chlorine is a 3.0. If you look at your electronegativity table, you would see that. The other choices are all the same elements, so they have to share evenly. Number 9, write the correct Lewis dot structure for an atom X whose electron configuration is 1s2, 2s2, 2p3. Now remember, when you draw Lewis dot structures or electron dot structures, you're only showing your valence electrons. So notice I've underlined the 2s2 and 2p3 part of the electron configuration here. That is your highest occupied energy level. That's where your valence electrons are found. So if you add up the superscripts in the highest occupied energy level, you see that you have 3 plus 2 is 5 valence electrons. That means the element is nitrogen. So if you were to draw the electron dot structure for just the atom of nitrogen, you would draw the symbol N and you would put 5 valence electrons around it. Now keep in mind, this is for an atom, and atoms are not stable yet. This is not the Lewis structure for a diatomic nitrogen. It's just for an element. So this goes back to the chapter 4 where we learned about Bohr models of just an atom and how to draw electron dot structures. Number 10, what is the bond angle around the carbon in CH4? So if you look at the Lewis structure for methane, CH4, you would see that it's tetrahedral. So that means the bond angle around that carbon there is 109.5 degrees. Number 11, multiple bonds can occur with which 3 atoms? This is straight from your notes. Carbon, oxygen, and nitrogen. Remember, it spells con, like a con man. Con man might trick you, right? How would they trick you? By wearing multiple disguises, maybe. So I think multiple bonds, multiple disguises, con man. Okay, so CON. Those elements typically will be found in compounds that have double and triple bonds. Number 12, metals bond with metals is when you have a metallic bond. And in a metallic bond, the electrons that are being utilized are delocalized or constantly moving around. Number 13, 14, and 15 all refer back to something we looked at in the notes with this energy diagram that we see here. So in the energy diagram, notice as you go up the y-axis, energy is increasing, and on the x-axis, the distance between the nuclei is increasing as you go from left to right. Notice in the beginning at point A, the energy is at its highest, and that's when we said the atoms had not met yet, so that's when they're very unstable. High energy is very unstable. We said as the atoms come together, the energy starts to decrease, and as they actually form their chemical bond at the bottom of this little trough here, that is the lowest energy point. If you look, it's the lowest energy point on the graph. So that's where you would have your bond actually forming at the lowest energy. And then a little bit after the bond forms, as the bond is stabilizing, the energy may increase a little bit due to some repulsive forces that are occurring there, but eventually it levels out and it just reaches what we call equilibrium. And this, if you were to continue this, it would be a flat plateau across. So at point A is at which point are there no significant forces between the atoms. That means they're very unhappy, very unstable. They've not met yet. That's going to be at point A at the high energy. 14, at which point are the repulsive forces stronger than the attractive forces? That's at point C. Again, that came straight from the notes. Go back and look at the notes if you have forgotten about that. You took those notes on the remote learning day on 11/25, I think it was. And then for 15, at which point are the atoms forming a chemical bond? That's at the lowest point. That's when the bond's forming. That's at your lowest point here, point B. You also need to be able to use your electronegativity chart to classify the bond type as to whether it's ionic, polar covalent, or nonpolar covalent. So remember, I will supply you with the actual values for electronegativities, but you need to know the ranges here that I have. 16, you should have gotten 0.7, and that's polar covalent. For 17, 2.5, and that was ionic. For 18, 1.0, and that's polar covalent. For 19, the difference was 0.5, and that's polar covalent. For 20, you got I2, which is I bonding with itself. So the difference is 0, and that's nonpolar covalent. For 21, you have 1.9, ionic. 22, the difference is 0.1, and that's nonpolar covalent. So be able to take your electronegativity values, subtract them, and then classify the bond type based on the difference in electronegativity. Now the next section of the review sheet is on hybridization. And so on the test, you're going to have a molecule that's going to be a hydrocarbon, kind of like this. And you're going to be asked some various things about the molecule. Hybridization, remember, is when you're mixing your s and your p orbitals. And hybrid means you have blended things. In this case, you're blending the s and the p orbitals. If you have forgotten about that, you may want to go back and look at that video lesson on hybridization. But let's take a look at the answers to 23 through 27. So there's a couple of these where I'm asking about a bond angle measure. So to get your bond angle measurements, you have to go back to the Vesper theory. Remember, with Vesper theory, we learned about the different bond angles based on the Vesper shape. So to get a bond angle, you do want to rely on the information from the Vesper theory. So that means you want to think in terms of if it's linear, it's 180. If it's bent, it's 105. If it's trigonal planar, it's 120. If it's a trigonal pyramidal portion of the molecule, it's 107. And if it's a tetrahedral portion of the molecule, it's 109.5. So you have to base your bond angle measures on the Vesper shape around that atom. So let's look at 23. It says, what is the bond angle labeled A here? So if you take a look at the bond angle A, it is surrounding the carbon that I have numbered carbon number 3 right here. So what you want to do is you want to sort of block out the rest of the molecule and look at what's on that particular carbon. Well, this carbon has 2 atoms attached to it and no lone pairs. That means it's a linear portion of the molecule. And since it's a linear portion of the molecule, the bond angle on all linear molecules is 180 degrees. So that's why the answer to 23 was 180. For 24, it wants to know the hybridization of carbon number 1. So with hybridization, you're mixing your s and your p orbitals. So the easiest way to figure out hybridization here is to count how many sides of the element has something on it. So in this case, we're looking at carbon number 1, which is the carbon I have numbered here, carbon 1. So let's focus on that part of the molecule and let's see how many sides of that carbon has something on it. How many electron domains are there? So I always kind of treat it like it's in a square. So there's something on the top, there's a single bond on the right, a single bond on the bottom, and a single bond on the left. That means 4 sides of this carbon are surrounded. It has 4 electron domains. So you're going to count to 4. So you're going to count, instead of 1, 2, 3, 4, you count S, P1, P2, P3. Again, that's S, P1, P2, P3. So it's sp3 hybridized. For 25, the hybridization of carbon number 2. So we're looking at this carbon here. So let's look at that portion of the molecule. So carbon 2 has 1, 2, 3 atoms on it. So it's trigonal something, right? Well, in this case, since we're looking at hybridization, we're going to look at the fact that it has 3 electron domains. It has 1 electron domain on the left, 1 on the top, and 1 on the right. There's no electrons beneath it, so this is not an electron domain. An electron domain is a side of the element where electrons are found. So this has 3 electron domains, so we're going to count to 3. S, P1, P2. That is sp2 hybridized. Number 26 wants to know bond angle labeled B. So let's look over here where I have B labeled. If you look around that particular angle that I'm showing you, I know it appears to be 90, but remember we don't have 90-degree angles in our first 5 basic shapes. So what you want to do is look at the carbon and see what's on it. So this carbon has 1, 2, 3, 4 atoms attached to it. That means it's a tetrahedral part of the molecule. This is tetrahedral around carbon number 5. So that means that angle is 109.5 degrees. Number 27, the hybridization of the nitrogen. Well, there's only 1 nitrogen in the molecule, so let's take a look at him here. The nitrogen has 3 electron domains. So the electron domains are 1 on the left, a single bond, 1 on the top, that's your lone pair, and a double bond on the right. So there's 3 electron domains, there's nothing beneath them. So again, 1, 2, 3 electron domains means we're counting to 3, S, P1, P2. So that's it for the hybridization. The next part of the worksheet, the review sheet, was some Lewis structures and practicing your Vesper theory. Remember, when you're asked to give a Vesper shape, you're also going to get the bond angle. So don't forget to get the angles along with it. Now, for your Lewis structures, first off, you want to always show your addition of your valence electrons. So we have 8 valence electrons here. When you draw your Lewis structure for ammonia, you have NH3. The hydrogens have their duet. The nitrogen gets the last 2 electrons to complete his octet. This is trigonal pyramidal, and the bond angle is 107 degrees. You should have gotten 32 electrons on the silicon tetrafluoride. You have exactly enough electrons to give everybody their octet. This is tetrahedral and 109.5 degrees. For the water, there are 8 electrons when you add up the valence electrons. Your Lewis structure should look like this. Your oxygen should have a single bond on 2 sides of it, and it should have a lone pair and a lone pair. That gives him his octet. Again, remember, hydrogen follows the duet rule. This Vesper shape is bent, so the geometry of the molecule is called bent or angular. And the bond angle on bent is always 105 degrees. For 31, the cyanide ion, 10 electrons total. Carbon and nitrogen have a triple bond between them. Don't forget, if it's a polyatomic ion, you put brackets around the structure and put its charge as a superscript. This is linear and 180. And for 32, the silicon dioxide, 16 total electrons. Once you have distributed all of your electrons, keeping it as symmetrical as possible, you get 2 double bonds. All right, and you have your completed octet of electrons around the oxygens. This is linear and 180. All right, so those are the answers to the Chapter 7-8 review sheet. So make sure that you understand how to draw the Lewis structures, how to classify your Vesper shape, and also you want to make sure you understand the information from the multiple choice and the classifying the bond angles. Now, the last little thing I want to point out here before I sign off for this screencast is just to remind you of some worksheets to study that cover quantum numbers and electron configurations. Now, these are all from things we did before break, and you already have all the correct answers, or we have gone over them in our lessons, in our classes. So you should have all of these corrected, and if not, you can go back to the recordings and find the answers. I took pictures of the worksheets just to point out to you, so let me just kind of scroll through them. The first beginning of the very beginning of quantum numbers started off here with this worksheet called the Chapter 5 Review of Notes. So make sure that you study over that information, Chapter 5 Review of the Notes. That was 2 pages, and we had several examples here of quantum numbers that we did going forwards and backwards. Then the next day we did quantum numbers electron configurations worksheet. So again, find your NL, M, and S, be able to go backwards and find the element from the quantum numbers. Make sure you're familiar with the who am I questions. We talked about those. Make sure that you can use the 2n squared rule. That's in the notes. We did several examples in the notes if you want to have more of those to look over. Electron configurations, make sure you can do a longhand or complete. Make sure you can do a shorthand also. Be able to take an electron configuration and determine who the element is from the electron configuration. Another worksheet that will be a good one to look over, and again, you had the answers to this in one of the I think early last week, so you should already have these corrected if you've been keeping up with your assignments. So the electron configurations quantum numbers review number 2. Okay, so make sure you can do those kind of things. 5-5 practice problems, where you're asked about writing an electron configuration and then determining the number of unpaired electrons. So make sure you can look at your electron configuration and tell how many unpaired electrons you have. And then we have the Chapter 5 Quantum Numbers Electron Configurations Review Worksheet. Now, of course, you don't have to know all of these. The test is not going to be extremely long, but these worksheets here are worksheets that will review back over with you things you need to understand and be able to do, like finding the highest occupied energy level, the number of valence electrons, the number of core electrons, and identifying an element from its electron configuration. Don't forget that you need to be able to also tell if an electron configuration is excited, ground state, or impossible. Now, the last worksheet that I took a picture of here was the one that had you reviewing over the 2 exceptions, copper and chromium, that occur with your electron promotion. So again, these we've already answered. You should have all of these answered and corrected because we have gone over all of these in class or in the video lesson that I have made with the answer keys. So that's all of what I want you to make sure you're familiar with for the test. So study that information. Our unit test will be tomorrow. You will take part of it in class for the short answer, and then you will have a portion that you will take out of class that will be multiple choice. Have all of your questions ready for tomorrow. Anything I need to go over with the first 15 minutes of class, I will be glad to do so. Thanks, and see you tomorrow.